Okay, welcome back and thank you for listening. If you're joining me in this video, I hope that you've kind of already gone through and watched the first 5. If you haven't, I recommend doing that. In the last video, I spoke at length about tuples. And if you remember, we created a tuple by essentially creating an object. So let's just say tuple 1 equals that, and you had the parentheses, and within the parentheses, you had a few different objects, however many you wanted, delineated with separated by commas. In this video, we're working with a more powerful, different type of a list called a list. Tuples were immutable, which meant we couldn't change them. Lists are far more powerful because once you create a list in memory, you can change it. It is mutable. And lists are created in a little different way. Instead of using parentheses, we are going to use brackets, an open and a closed brackets. And if you look here, I have new list, names, and names too. All of these are lists. If you notice, we have objects in our list, we have integers in our list, floats, and even new strings in our list. And to print off a list, all you have to do is the same exact thing as with a tuple. You simply use the print function and type in new list between parentheses, and you have the output of your list. So why are lists important? They're important because of the fact that you can actually change them in memory. They're important because you can update, clear, delete, alter lists as you go through and run your Python script. And you're going to find yourself, like I do, in every single project relying on this mutable function aspect of lists. And that's one of the reasons why I find myself using lists more frequently than tuples in my DH projects. So let's look at some of the ways in which we can alter lists in memory. I'm going to print off new list once again, and it's going to print it off just as it is. But I'm going to use another function after I print it off the first time. I'm going to use the append, A-P-P-E-N-D function, and I'm going to add another new string. I'm going to add a new object into that list, and what I'm going to do is I'm going to demonstrate to you what I mean by the fact that you can change it in memory. When I run the code, this is what we see. We see the first print being called here, and we see the second print being called here. Notice that the list has been updated in memory. We see that it has changed. This is something that we could not do with a tuple, and this is something that makes lists very, very powerful in Python. Let's do something similar, though, and demonstrate this further. Let's use the clear function, which is essentially going to clear all of the data in the list. When I run the code, we see once again it print off 3 different times now. Once when it's just non-altered, once when it's been appended, and once when it's been cleared. In other words, we have been able to update the list in memory by clearing specific functions. So that's kind of how you modify a list on a basic level. What if you want it to be a little bit more complex? Let's say we wanted to, let's go ahead and delete this. Let's say we want to make a new list called names3, and we wanted to combine names, this list here, and names too. For some reason, we want all of these people to be in just one list. In Python, it's as simple as typing this bit of code. Names3 equals names plus names2. And what you're going to see is that names3 is going to print off all of these, a new list that is comprised of both of these lists. So if you see down here in the output, now everyone is organized just the way we want them. However, they're not in alphabetical order. How can we fix that problem? Quite simply, all you have to do is type in names.sort. Let's print off names again. Oop, names3. There we go. And now what we're going to see is that when we use the sort function, they're going to be sorted alphabetically. Let's copy and paste this so you can see. Here is the first print function when we didn't sort it, and here's the second one after we did. Now everyone is alphabetical. This is fantastic for when you're working with large data sets and you need to look at them in some kind of alphabetical order. But we see here that once we use the sort function, this list has been changed in memory. It's now been updated. What, however, if you need to delete a specific number or item in that list? Let's say for whatever reason we need to delete the first item in names. So what we're going to do is we're going to delete names, and we're going to delete the 0, the thing that falls in the 0 function. So I'm going to do print off names using Python 3, so we have to do parentheses. So now what I am doing is I am simply pulling up this list here, names, and I'm deleting the thing that's in the 0 position, and then I'm going to reprint it. And what we see now in the output is that poor Tom, has been deleted from our list. Now it's just Jerry and Bob by themselves. That's unfortunate. If we want to remove a specific person from a list, so let's create names3 once again, as names plus names2. We're going to print off names3. Let's say we want to remove. We don't like Jim. Jim, we never liked The Office for whatever reason, and we don't want to see Jim as part of this list. So now we're going to print off names3, and we're going to use the remove function here to remove a specific person from this list, this combined list of these two individuals, or these two lists. And what we notice here in the output, print it off up here, is that Jim has been removed. But wait, only one Jim has been removed. We still see this Jim over here. The remove function is only going to let you remove the first instance. In order to remove multiple instances of a name, you have to do some different things in order to do that. One of the ways you can do it, it's a bit expensive, for name and names3, remove this. If I were to run this code just like this, you're going to see that there is an error. Oh, that's why. And the reason why there is an error is because I am simply trying to remove something that doesn't actually exist in that list anymore as it's iterating through. If, however, I wanted to do this, try exception. You can see how cumbersome this is. There's better ways to do this. I'm going to talk about how to do this in more detail as we get further on in this series. But right now, I'm just simply doing this to demonstrate that you can actually delete something that occurs more than once in a list. Once we start working with our actual DH example codes, I'm going to show you how to do this in a bit more depth and explain what's actually happening here. But for right now, you can see that we were able to remove an occurrence of Jim, every occurrence of Jim in a list. So that's how you kind of remove something from a list. One of the things I find myself having to constantly know is the length of an item. And the way in which you learn the length of a list is you use len, the len function. That's going to give us the length. And we're going to print off the length of names3. And what this tells us is that the length of names3 is 7. You might be thinking to yourself that that is kind of useless knowledge. Why would you even want to know that? The reason why is because getting the list of a length will very oftentimes tell you how many times to iterate through something. So let's say for I and names and range, let's do this so you can actually see length being used. For I and the names, print I. So what we are going to see here is, delete this so you don't get confused. We're going to see how many iterations there are in a list, but let's say we want to actually see each individual in a list. Let's do this for names3 so you can kind of see a better length. So it's going to be a length of 7. And what you're going to be able to do, print, I made a mistake there. There we go, names3. What you can do is you can iterate through and manipulate each iteration of a list in a simple for loop. But in order to do that, you need to know the length of the list in some cases. In other cases, you can kind of just work through it without actually having to do that. But you will find yourself time and again having to figure out the actual list, the length of a list in order to iterate across that list in its entirety. So learning that len function, that len, is going to be very useful. So simply just, in this case, I'm going to print it off. So to print off the length of names3. So it's len, and in parentheses, the length of the thing that you want to see the length of. So in this case, names3. So that's how you get the length of a list. Let's say for whatever reason, though, you want to actually add these two lists together, but you want to have a new list that treats them, name3 equals names. Explain what I'm doing in just a second. Let's say you want to actually have this list, but you want to have them stored within a tuple. So this is how you can actually do that. Notice down here when I print off names3, I have returned a single object consisting of two lists. And what this has done is it's essentially just created a tuple. Let's run this now. If I want to create a list of two lists, I add a bracket around it, which tells Python to create a list of two different lists. So now I'm basically combining these lists, but storing them separately within a new list. I'm going to deal more with this in later videos, but for right now, I wanted you to get the sense that you can combine lists in a myriad of ways. You can make them a new list that's just names, as we did before, names plus names2, like so. Or you can separate the two with a comma, which is going to return a tuple. Or you can do the comma and delineate these with a bracket, in which case you're going to get a list of lists. You're going to find that when you work with your GH projects that you're going to need to create lists and manipulate lists and combine lists in a myriad of different ways to perform very specific targeted functions. These are some of the basic ways in which you can kind of do that. But one of the things I find myself constantly doing is when I'm working with a list of strings, a list of names, what have you, I sometimes want to actually have all of those names kind of come together. So I'm going to combine these once again because I want just a single list. Oh, plus names2. So I'm going to print off names3 so you can kind of see what's happening here. But let's say I want to take all these names and I want them to be a single string. The way in which I'm going to do this is I'm going to use the special joined function. And what I'm going to do is I'm going to tell it to join all the items in names3 with nothing in between. And when I print this off, let's just make this names4 so we can kind of see what's happening here. Print names4. So right down here we see in the output names3 and names4. Names4 is a string of just a whole bunch of different names that were in names3 all kind of combined together. If we want a space in between them, we simply changed it to that. We add a space in between these two quotation marks. And we print that off. Now we see these names all kind of spaced out. You're going to find that this is a very useful function for when you're trying to do things like web scraping or just kind of trying to gather a whole bunch of data that needs to be read collectively. Again, this is going to be something that you need to know for very specific tasks. I'm just simply giving you the tools so that you can kind of have a sense for how to do it and some of the ways in which you can manipulate lists. You can also do other things with lists. You can, let's see, print off names3. There we go. You can do a lot of other things with lists, some of which I wasn't able to get to in this video. But again, this was just to give you a basic idea about how to kind of work with lists and call lists. You're going to find that you're going to often have to look up very targeted things that you need to do to interact with lists online. I couldn't get through all of them in this single video, but this is just to give you an idea about how Python is storing data and this kind of data structure of a list, this relational data structure. In the next video, we're going to talk about the third and final way in which we can do this in Python, and that's with dictionaries, which are going to be a little bit more complex and a little more powerful than lists. So thank you for listening.